And the last one today is this Wireshark exercise, which is a little more in depth than a typical Wireshark exercise you might find in Cisco. You know, in the Cisco class, you learn all the protocols like spanning tree protocol and DNS and DHCP and all that. But here we're going to analyze what an attacker did, like we did in those Splunk projects. So there's first you do some really simple things here to just get you started, like finding FTP passwords and HTTP passwords. And those are things you've probably done in a Cisco environment. And there's one where you can do basic authentication, which is just base64 encoded username and password. But the interesting thing, I got this from a capture the flag contest, is APT capture. This is an interesting puzzle. And so if I open this, it's going to launch in Wireshark somewhere. Oh, here we are. Good, right in front of me. Good. So there it is. I've got, good. Okay. I've got 72,000 packets, and I don't care about the version number. All right. So here's my Wireshark, and there's a lot of data in here. And the first question is, what kind of protocols are here? So I'm going to do statistics protocol hierarchy. And now I get this table, which shows me the protocols that are in here. So I have Ethernet and IP version 6 and IP version 4 and TCP. Here's TLS and SSH. And if you notice, those are the only two encrypted protocols. All of them are unencrypted, except I have just one packet of SSH. So that's ridiculous. That's not going to be enough to include anything. And I have some TLS packet. I got 51 packets of that. So TLS appears to be the interesting protocol that might have encrypted data. And so if I right-click, apply as filter, selected, and close, I now see what's going on here. And you notice TLS should be going to port 443, but it's going to 8443. So that suggests that something a little strange is going on here. And that's the start. So now we're going to find the tool used for encrypted communication. And one way to do that is you could filter for traffic going to port 8443 and you would get this, but you're not going to be able to read it. This is a TLS connection. You have client hello, server hello, key exchange, and then you get application data. And from this point on, the application data is going to be unreadable encrypted junk. So I don't know what's going on here. I know something happened here, but I can't figure it out. But what happened here, in fact, is this is a malicious process launched by the attacker on the machine. And they started a server to start listening on port 8443. So they had to execute a command line that included the string 8443. So I can do, there's a couple of ways to do this. But one way is frame contains, one of my favorite parts of Wireshark, 8443, because this is a grep search, just like what I was using in Splunk. This will just find frames that contain the literal text 8443, and there aren't too many of them. And if I look at the timeline, there's a couple of packets at 97 seconds, then there's some traffic at 1118, and then there's some traffic around 1800. So I might want to analyze these different regions. If I right-click this and follow TCP stream, I'll see the information, the way it looked to the end user. So this is an HTTP web page being downloaded, and it's just one all big web page. So this is completely boring, and that's not the fun part. So let's go back and try again. 8443, enter to take effect. Okay, so the 1118 second stuff is not interesting. Let's try the 1800 stuff. Follow TCP stream. And this is the good stuff. The bad guy got an ability to execute commands on my machine, and here they are being executed. They do ID to see who they are, to find out their root. Then they do uname -a to find out what version of Linux is running. Then they do IPA to see the IP address. Then they do a list of running processes. This is all standard hacker looting a box. And by the way, it's the same thing forensic examiners do and incident responders do, like we just did in Velociraptor. When you're trying to find out what's going on in the box, you list the processes, you list the network connections, you do all the usual stuff. There's the processes. We can see what the bad guy did. Now they went to the temp folder, which is commonly used because every user has the right to store files there. And I wonder if I can zoom in and make this bigger. I think I can. All right, so now, then they ran netcat to listen on port 31337, and which is another one of those ports hackers use a lot because it spells out elite in leet speak. And they're going to listen on that port, and whatever data comes in, they're going to put it in a file called SOCAT. And then they transmitted the SOCAT binary from a remote server onto the box, adding this executable. Now they did ls to see that they have SOCAT. Now they need to generate a key. This is OpenSSL being used to generate an RSA key, 1024 bits. Now they check to make sure they've got the key, and this is where they use OpenSSL to turn it into a certificate, an X509 certificate, just like web servers use. And now they take this key and put it in a PEM file. That's the format that it might be needed in. They change the permission to 600, and this is where they now take the secret and they send it unencrypted over the network to a server on port 31337. So we're going to be able to find the encryption key in this network traffic unencrypted. And here is where they create the HTTPS server. This is SOCAT listening on port 8443 and using that certificate to run a local HTTPS server. So now they can communicate with the box and use encrypted data going back and forth. But notice, even though they're using encrypted data, they transmitted the key unencrypted. So that's what this project is. After you find this, now you have to retrieve the key, feed it into Wireshark, and let Wireshark decrypt the encrypted traffic, and then you can see what they've been doing. So it's pretty cool. Well, I thought you might like this one. I really like it better than it's more security oriented than your average Wireshark project. And there's a bunch of things to stop here, and you have to actually decrypt things to find it. And there's port knocking and so on. So very much like that Splunk project, there's several malicious things that bad guys do here, and you get to practice detecting it with Wireshark. So I'm going to stop this recording.